You are holding a rock. It is black, smooth, and sharper than anything else you have ever touched. You did not make it. You found it near a volcano, wedged into a ridge of coarse gray stone, and when you cracked it with another rock, it broke into a curved edge so thin it could slice skin without you feeling it. Sharper, edge for edge, than surgical steel. This is obsidian. Volcanic glass, roughly 700,000 years ago, at a site called Kariandusi in Kenya's Rift Valley, a human ancestor, Homo erectus, picked up a piece of this same material and used it as a tool. That is the first known moment a human held glass. Nature had a 5,000-year head start. Glass existed on this planet for billions of years, before anyone figured out how to make it. Lightning struck sand and left behind hollow tubes of fused silica called fulgurites, root systems of glass burned straight down into a dune in a fraction of a second. Meteorite impacts melted entire desert floors into sheets of pale yellow crystal. Volcanoes poured out rivers of molten rock that cooled into obsidian fields sharp enough to butcher a mammoth. Nature had been making glass since before life existed, and nature was good at it. No furnace, no recipe, no hands, just heat and silica, and enough speed to skip the crystal step entirely. Some of that natural glass, the kind formed by a cosmic impact in the Libyan desert, comes out nearly 98% pure silica. Hold on to that number. 98%. It matters later. For hundreds of thousands of years, humans used glass without once understanding what it was, or that they could make it themselves. So how did we get from a volcanic rock to the screen you are looking at right now? The answer covers 5,000 years at least 4 accidents nobody planned, and a race in purity that is in a sense still being run. What glass actually is. Let's start with what glass actually is, because most people get it wrong. Glass is not a liquid. You may have heard the claim that glass flows slowly and that old cathedral windows are thicker at the bottom because the glass has been oozing downward for centuries. That is a myth. Physicist Edgar Dutra Zanato at the Federal University of São Carlos in Brazil calculated in 1998 that it would take longer than the age of the universe, over 13.8 billion years, for cathedral glass to show any measurable flow at room temperature. The uneven thickness is a manufacturing artifact. Medieval glassmakers spun molten glass into flat discs that were naturally thicker on one edge, and glaziers installed the heavy side at the bottom. The glass did not move. It was made that way. What glass actually is something genuinely strange. It is an amorphous solid, atoms arranged in a disordered pattern, like a liquid frozen in place, but with the rigidity of a solid. Cool most liquids slowly and the atoms line up into neat, repeating grids, crystals. That is ice, salt, metal. Cool certain liquids fast enough, and the atoms never get the chance to organize. They stop moving mid-chaos. That is glass. A material caught halfway between two states of matter, permanently stuck in a moment of transition. It can be transparent, shaped, colored, made thinner than a human hair, or thicker than a bank vault wall. And it all starts with sand. The main ingredient in most glass is silicon dioxide, the primary component of common sand. Pure silica melts at roughly 1,713 degrees Celsius, far too hot for any ancient furnace. Add a flux, a material that lowers the melting point, and the temperature drops to something manageable. Ancient glassmakers used natron, a mineral made mostly of sodium carbonate, found in dried lake beds like Wadi Natrun in Egypt. Mix sand with natron, heat it to roughly 1,000 to 1,100 degrees Celsius, and the silica melts. But there's a catch. Glass made from just sand and natron dissolves in rain. Add a stabilizer, usually lime from crushed limestone or seashells, and it holds. 70% silica / 15% soda, 10% lime, that formula, give or take a few points, is essentially the recipe used in most glass made on Earth today. 5,000 years old, and it still works. Now, who figured this out first? The Roman writer Pliny the Elder told a story that has survived 2,000 years. Phoenician merchants, camping on a beach near the river Belus, rested their cooking pots on blocks of natron they were carrying as cargo. The fire fused the natron with the sand beneath it, and molten glass flowed out from under the pots. It's a wonderful story. It is also almost certainly false. An open beach fire reaches maybe 600 to 800 degrees Celsius, nowhere near hot enough, even with natron lowering the threshold. Pliny's story is a foundation myth, not a scientific account. The real origin is messier / less romantic and much older. The earliest man-made glass objects are small beads found in Mesopotamia and Egypt, dating to roughly 2,500 to 2,300 BC, over 4,500 years ago. The most widely accepted theory is that glass was discovered by accident during the production of faience, a quartz-based material coated with a glassy glaze. When silica-rich material mixed with alkali flux in a hot kiln, the surface sometimes vitrified into a thin layer of actual glass, and someone noticed it could be scraped off and used on its own. Another theory points instead to the glassy slag left over from smelting copper. Either way, nobody set out to invent glass. They were trying to make something else, and got glass as a byproduct. That is the first accident. Keep counting, there will be at least 3 more before this story is over. And here is something most people don't know. Egypt and Mesopotamia appear to have developed glass independently of each other. Archaeologist Andrew Shortland, at Cranfield University, used laser ablation mass spectrometry in 2012 to compare the chemical signatures of early glass from both regions. The Egyptian glass carried trace elements consistent with Egyptian raw materials. The Mesopotamian glass carried different ones entirely. 2 civilizations, working with the same basic chemistry, stumbled into the same accident on their own, in parallel, without knowing the other had done it too. For its first 1,000 years, glass was not a common material. It was a luxury on the level of lapis lazuli / turquoise and gold. During the Late Bronze Age, roughly 1,550 to 1,200 BC, glass was traded as a diplomatic gift between kings. The correspondence found at Tel El Amarna, exchange between Egyptian pharaohs and other Near Eastern rulers around 1,350 BC, includes actual complaints about the quality of the glass that was sent. One ruler tells the pharaoh, in essence, that the glass he received was terrible. The most important ancient glass workshop ever discovered sits at Amarna itself, the short-lived capital built by Pharaoh Akhenaten around 1,350 BC, and abandoned within a generation. Archaeologists there, from Flinders Petrie's first excavation in 1891, through more recent excavations by Paul Nicholson of Cardiff University, conducted between 2004 and 2007, found glass rods, canes, ingots in multiple colors, partially finished vessels, and the remains of the furnaces that made them. What they pieced together was a 2-stage process, not a 1-step melt. Raw materials were first partially melted into a rough, impure mixture called frit, cooled, then crushed by hand, and remelted a second time at higher temperature to burn off the bubbles and produce clear glass. That is not a simple operation you stumble into twice. That is industrial chemistry, with quality control, performed 3,400 years ago, in a city that existed for less than 20 years. And here is where the story folds back on itself. In 1922, Howard Carter opened the tomb of Tutankhamun and found a carved scarab beetle set into a ceremonial breastplate. For decades, it was cataloged as an ordinary gemstone. Not until 1998 did Italian mineralogist Vincenzo De Michele examine it with infrared spectroscopy and confirm what it actually was. Libyan desert glass. The same natural glass we started this video with. Nearly 98% pure silica, formed roughly 29 million years ago by a meteorite impact, scattered across the sand between Libya and Egypt. Egyptian craftsmen found a piece of glass older than any human civilization, thought it was beautiful, and carved it into a sacred symbol for a dead king. They had no idea they were holding proof that nature had already won this race by a margin of millions of years. The earliest glass vessels were not blown. They were core-formed, a technique that appeared around 1500 BC. A craftsman shaped a core of clay and dung around a metal rod, dipped it into molten glass, smoothed the surface on a flat stone called a marver, then scraped the core out once it cooled. The result was small, colorful, and it took hours to make. For over 1500 years, that was the only way to make a hollow glass object anywhere on Earth. Then, around 50 BC, on the coast of what is now Lebanon or Syria, someone put a blob of molten glass on the end of a hollow iron pipe. And they blew. Before glass blowing, one vessel took hours of skilled labor. After it, a trained craftsman could make one in minutes. Dozens in a day. The earliest blown vessels turn up in Jerusalem, dating to the mid-1st century BC. Scholar Marianne Stern has argued the technique likely grew out of workers already familiar with blowing through tubes for metalworking bellows. Someone took that same motion, pointed it at molten glass instead, and accidentally invented mass production. One of the earliest named glassmakers in history, Ennion of Sidon, signed his mold-blown cups in Greek. Ennion made this. His work has been found from Israel to Italy, held today in museums including the Met in New York, one of the first brand identities in the history of manufacturing, stamped onto a cup 2,000 years ago. The Romans didn't invent glassblowing, but they industrialized it, running workshops from Cologne to Alexandria. The writer Strabo noted around 20 AD/ that a glass drinking cup could be bought for a single copper coin. Glass had gone from rivaling gemstones to costing less than a meal, and the Romans used it for something nobody had tried before. Windows. Evidence of Roman window glass survives at Pompeii, preserved under the ash of 79 AD. Small, thick, not fully transparent, but enough to let in light while keeping out the weather. But the Romans also made something modern craftsmen still struggle to replicate. The Lycurgus cup, now in the British Museum, is a 4th century cage cup that changes color depending on how you light it. Opaque jade green from the front, translucent ruby red from behind. For centuries, nobody could explain it. In 1990, researchers including Ian Freestone examined it under a transmission electron microscope. And found gold and silver particles 50 to 100 nanometers wide, too small to see, bending light through what physicists now call surface plasmon resonance, the same effect modern researchers use in medical biosensors. The Romans built nanotechnology 1600 years before anyone had a word for it, without knowing what an atom was. Diễn xuất chậm lại rõ rệt ở câu hỏi trung tâm, đây là bản lề của cả video. So if that could happen by accident, the real question isn't whether humans would ever out-engineer a volcano. It's how long it would take. For the next 1,000 years, the center of glass innovation kept moving. Islamic glassmakers working in Syria and Egypt, between the 7th and 15th centuries, mastered enameling, gilding, and metallic staining techniques Europe wouldn't match for hundreds of years. The mosque lamps produced in Damascus and Aleppo during the Mamluk period are still among the most celebrated objects in Islamic art. Then Timur sacked Damascus in 1400 and reportedly marched its glass workers to Samarkand, gutting one of the finest glass industries in the world almost overnight. The next center was Venice, and Venice treated glass like a state secret. In 1291, the Republic ordered every furnace moved off the mainland and onto the island of Murano, about 1.5 kilometers across the lagoon. Officially, that was fire prevention. Furnaces did burn down wooden cities. Actually, it was control. An island is easy to watch. Glassmakers on Murano received extraordinary privileges in exchange for staying put. They could carry swords, a mark of nobility denied to most citizens, and their daughters could marry into aristocratic families. But they were forbidden to leave the Republic. If one fled abroad, the state first tried, diplomatically, to persuade them home. If that failed, their families back on the island could face the consequences instead. Around 1450, a Murano glassmaker named Angelo Barovier developed something the world had never seen, cristallo, nearly colorless glass, clear enough to pass for rock crystal, made possible by carefully purifying his raw materials and using manganese dioxide to cancel out the green tint left by iron impurities in the sand. It made Venice the undisputed capital of glassmaking, for the next 2 centuries, clear enough that France wanted the secret badly enough to lure Murano workers to Paris in 1665, some of whom later died under circumstances still whispered about as Venetian poisoning. Those workers eventually built what became Saint-Gobain. By the 1680s, their glass covered the Hall of Mirrors at Versailles, 357 mirrors, a political statement in reflective silica. Mirrors themselves stayed dim and metal-backed until 1835, when German chemist Justus von Liebig replaced toxic mercury with a thin chemical layer of silver, essentially the same process still used in the mirror on your wall today. Glass was also, quietly, inventing science. Eyeglasses appeared in northern Italy, probably Venice or Florence, around 1286. Historian Vincent Ilardi has argued they extended the productive reading life of scholars by 15 to 20 years, before spectacles, presbyopia, a near-universal condition by age 40 or 50, simply ended anyone's ability to read fine print. When the printing press arrived around 1452 and flooded Europe with books, demand for lenses exploded right alongside it. Glass and the printing press fed each other. Without one, the other almost certainly moves centuries slower. In 1608, a spectacle maker named Hans Lippershey filed the first patent for a telescope. The following year, Galileo built his own improved version, pointed it at Jupiter, and saw 4 moons orbiting the planet, publishing the observation in March 1610 in a short book called Sidereus Nuncius, the Starry Messenger. 4 dots of light, seen through 2 curved pieces of glass, overturned the idea that everything in the universe revolved around Earth. On the opposite end of the scale, a self-taught Dutch draper named Antony van Leeuwenhoek, with no formal scientific training at all, ground tiny near-spherical glass lenses that magnified up to 275 times. Using single-lens microscopes he built himself, he became the first person to see bacteria, in 1676, and what he called animalcules swimming in a drop of water, sperm cells, in 1677, describing them in letters mailed to the Royal Society in London. 2 pieces of shaped glass, one pointed at the sky and one pointed at a drop of water, and between them, they proved the universe was bigger and smaller than anyone had imagined. Then, in 1903, French chemist Edouard Benedictus knocked a glass flask off a shelf in his lab. It cracked, but it didn't shatter. The pieces stayed together, held by a thin film of cellulose nitrate that had evaporated and dried along the inside of the glass. He patented laminated safety glass in 1909. Every car windshield on Earth today descends from that accident. That's accident number 2. In 1952, engineer Alistair Pilkington had an idea that, for once, wasn't an accident at all. Pour a continuous ribbon of molten glass onto a bath of molten tin, and let it float and spread into a perfectly flat sheet under its own weight. It took 7 years and roughly £7 million to perfect. Pilkington brothers announced the float glass process in January 1959. Today, over 90% of the world's flat glass, including the window nearest to you right now, is made this way. This is the moment the story changes. Every technique before this one, faience, core forming, glass blowing, cristallo, even the safety film in Benedictus's dropped flask, started with a person noticing something they didn't plan for. Float glass started with a person doing the math on tin's melting point, glass's density, and gravity, before a single sheet was ever poured. For the first time, humans weren't stumbling into glass. They were engineering it on purpose. In 1966, engineer Charles Cow proposed something that sounded absurd, that light could carry information down a strand of glass fiber if the glass were pure enough. At the time, the best fiber lost so much light over distance it was useless, a loss of roughly 1,000 decibels per kilometer. Cow's insight was that the loss wasn't a fundamental property of glass. It was impurities. Purify it enough, and light could travel for kilometers. In 1970, researchers Robert Maurer, Donald Keck, and Peter Schultz at Corning Glassworks produced fiber with losses below 20 decibels per kilometer, using fused silica doped with titanium, and crossed the line from useless to revolutionary. Today, hundreds of millions of kilometers of that fiber lie coiled under the ocean floor, and more than 95% of all international internet data, this video, a phone call to another continent, a bank transfer, travels through it at the speed of light, through threads thinner than a human hair. Diễn xuất, đây là điểm trả loop chính, nhấn rõ, chậm lại, để khán giả kịp nhớ lại con số đầu video. Remember the number from the beginning of this video? 98% pure. The best glass nature ever made, formed by a meteorite roughly 30 million years before any human existed. Modern optical fiber runs at over 99.9999% pure silica. It took 5,000 years, but humans didn't just catch up to the volcano. They lapped it. Charles Kao won the Nobel Prize in Physics in 2009 for making it possible. And the last accident. In 1960, Corning developed an ultra-strong chemically strengthened glass called ChemCore, tested it successfully, found no market for it, and shelved it. It sat in a filing cabinet. Then, in 2006, Apple needed scratch-resistant glass for a new touchscreen phone. And Corning's CEO, Wendell Weeks, remembered the dormant project. Steve Jobs was skeptical it could be done in time. Weeks reportedly told him "Don't tell us what we can't do." ChemCore came back reformulated as Gorilla Glass, shipped on the first iPhone in 2007, and by Corning's own count, is now in use on over 8 billion devices. That's 4 accidents. A volcanic rock nobody made, a kiln byproduct nobody planned, a flask nobody meant to drop, a filing cabinet nobody opened for half a century. Giz. So the answer to how we got from a volcanic rock to the screen in your hand isn't a straight line of inventors solving a problem on purpose. It's a 5,000-year argument with nature, one accident at a time, until the purity a meteorite made by chance, humans finally learned to make on demand. Glass is sand. That is all it has ever been. Heated, shaped, cooled into something transparent, and somewhere in the last 5,000 years, without ever quite meaning to. We got better at it than the planet itself. From that single material, humans built lenses that revealed the structure of the universe, fibers that carry the sum of human knowledge under the ocean at the speed of light, mirrors that let you see your own face, windows that let you see the world without feeling the weather, and a scarab carved from a 29-million-year-old cosmic impact, placed on the chest of a teenage king who never knew what it really was. You are surrounded by glass right now. You are probably looking through it. The only reason any of it exists is that someone, somewhere, noticed something strange happening in a kiln, and instead of scraping it away, looked closer.